Alright, hi everyone. So for today's lesson, we'll start a new topic, which is topic 5, integration. So same as the previous chapter where we learn differentiation, the content that you're going to learn will be built on your prior knowledge in Pure Maths 1. So that's why before we move into the new content, let's try to do a very quick recap on what you have learned previously. Alright, so let's start with the definition for integration. So I think you know that integration is actually a reverse process for differentiation. So if let's say we have an equation y equals to function of x, so when we actually differentiate it, then this is how we get the derivative, which is f prime x. So it's the same thing if let's say I have a derivative which is f prime x. Okay, when I actually integrate by f prime x, okay, this is how I get to my fx, which is my original function of y. Alright, so meaning that integration undo whatever that differentiation do. Okay, so the next thing that we learn is like the two technique of integration. So the first one would be the basic one. So if you have a function of ax to the power of n, so when you actually integrate it, then what you will get? So you will have ax, so power plus 1, and then divide by the power. Okay, and don't forget something very important in integration, you need to plus a constant. Okay, because you are undoing whatever that differentiation is doing. So you know that when you differentiate a constant, then you get 0. So that's why we need to plus a constant when we do integration. So same thing, we have the other one, which is what we call as composite function. So if you have a function that is ax plus b to the power of n, so when we actually differentiate it, then we will do the same thing, which is whatever in the bracket will stays the same. Then after that, power plus 1 as well, and then divide by the power. But don't forget, you will need to differentiate whatever is inside your bracket. In this case, it will be a. Okay, same thing, plus c. Alright, so those are the technique that we have learned previously. Okay, so the next one that we have learned is what we call as okay, so for this one, right, there is no range. So basically what we are doing is to find the original function y. Okay, so if let's say we have something like definite integral, so how is that look like? Okay, so you will have something similar like this. So meaning that integration. So for the range from a to b for the function of fx, then you need to integrate with respect to x. Okay, so when you actually solve this, then meaning that you have an integral, right? So in this case, we try to denote it as fx. Then you might need to solve it from the range from a to b. Okay, so for all the finite integral, you do not need to actually put in the part for plus the constant, because you can imagine when you try to substitute and when you try to solve it, right, the c will eliminate each other. Okay, so what you need to do is you need to use the upper boundary or the upper limit to minus the lower limit. Okay, so meaning that you will substitute to the integral then solve each other. So and then you will have some useful identity that you can use in integration. So for example, if let's say this is applicable to both infinite integral and also finite integral, all right? So if let's say you have something like this, okay, which your function has a constant, you can always take out the constant and then it will become k, and then what you need to do, you just integrate the function. Okay, so that's the first one, but you must make sure that your k is a constant. Okay, so the next one will be if you have something that is plus and minus. So if let's say fx and then plus or minus gx, yeah, so this is like the sum or the difference of the function. So when you have this case, then what you can try to do is you just split it into two. Okay, so you integrate for fx first, then after that you integrate for gx, then follow the sign that you have in your function, and then you plus or minus them together. Okay, so for the next one will be like, if let's say you have a to b and then fx dx. Okay, so meaning that you can see that the range here is from A to B, right? So the same thing, if we try to change this into B to A, what will happen? So if let's say when you use 3 minus 1 and when you use 1 minus 3, so you will get the same value in terms of magnitude, but then your answer will be the negative one. Okay, so you will get the exactly same value, but in a negative form. All right, so for the next one is, if let's say you have a plus b, a to b for fx dx, then you need to plus with another one with a continuous range, let's say from b to a. Okay, so when you try to solve this, we can actually just combine them. So you can imagine if you have a range from a to b, then b to c, right? So in another word, actually we can just combine them together and become a to c. Alright, so these are some useful identity that can help you to solve the integral. Alright, so let's move on to the next one. So I won't be spending too much of spaces here. So we already know that what is the application for differentiation in the previous chapter, which is like you have an equation of curve. Okay, then after that you will use it to actually find out the gradient function, right? Okay, so in this case, the gradient function. Okay, so equation of curve is what we mean as y normally, then the gradient function will be the one that is dy dx. Okay, so we know that from equation to curve, from here to here, then what you need to do is differentiation. So when you want to get back the equation of curve from the gradient function, then what you will need to do is the integration. Okay, so for the second derivative and so on, how do you get the gradient for the normal and the tangent and so on? So those, you should be familiar with it already. So it's basically the whole reverse process. Okay, so the next one, something special that you learn in integration, which we do not have this part in differentiation, is what we call as the area. Okay, so if you can recall, so for the area we learn two type of area. So for the first one is if let's say you have a area, okay, between a curve and also the x-axis, so meaning for example like this. Okay, then you have a range from a to b. All right, so as what you can see here, right, this is a area that actually enclosed by a curve and the x-axis, and also by the boundary of x equals to a and x equals to b. Okay, so in this case, what we have, when we try to solve it, then how is that going to look like? So it's going to be so this one is the function of x lah, so meaning the curve that you are drawing. So you will have an integral from a to b, then after that fx dx. Okay, this is how you solve for the area. All right, so for this one, right, you will have the idea of, let's say this is the y-axis, so like this. Okay, if let's say this is area A, then this is area B. Okay, so we know that this area is going to be like the curve between the curve and the x-axis, right? So that's why anything below the x-axis will actually give you a negative answer. So in this case, the area A will be a positive one, and for your area B, it will be a negative one. Okay, so for the second type is the other one, then the x-axis. So now it become y-axis. Okay, so meaning that it's an area that actually bounded by a curve fx. Okay, and also the y-axis, and also the line for y equals to a and y equals to b. So when you want to find the area, so what you will try to do is it will become a to b also in this case. what you will need to do. Yeah, so you can't do gfx anymore because you will need to differentiate with respect to y. Okay, so as what I have mentioned previously, so if it's an area between the curve and the x-axis, then you use dx. So your function must be in terms of x so that you can integrate in terms of x. Okay, so if you have something that bounded with the curve and the y-axis, meaning that you will do integration with respect to y. So since that you are integrating it with respect to y, so that's why your function will be in terms of y. All right. Okay, so the same thing, but in this case, it will be like this. So if you have an a, and you have a b here, okay, so the area actually at the right hand side of your right hand side of your y-axis, it will be a positive one. So for the area that is on the left hand side of your y-axis, it will be a negative one. All right. Okay, so let's move on to the next one where we learn the area between the line and the curve, and this is applicable also for like curve to curve. Okay, so if let's say we want to find out something like this. Okay, so you have maybe I do a line one so it's easier for you to see. Okay, so this line is gx, then we have another curve here, maybe like this. Okay, so the curve here is fx. Okay, so the intersection point is the range, and if let's say we want to find this, okay, so instead of like doing it one by one, so meaning that from here we can see that you will need to find the angle below the line, okay, and then you will use it to minus the area that you have under the curve, right? So this is what you will do so that you get the shaded area given here. All right, so we can always combine them together. So let's say if you want to find the area, it will be equal to a to b. So in this case, this is your gx, right? So this is between the line and the x-axis. So that's why you are going to integrate gx with respect to dx. Okay, then minus for fx. Okay, so in terms of solving this one by one, right, then we can always combine them together. Sorry, I have like very limited spaces today. So yeah, I'll write it here. So instead of doing it like two different steps, what we can try to do is you can see that they have the same range, right? So we can always combine them together. So instead of doing gx and fx, then what we try to do is we will have a to b. Then after that, straight away use the gx to minus the fx. Okay, so for example, if let's say your gx is like x plus 1, so for your fx is like x squared plus 1 minus 1. So you will just use the gx to minus your fx, then do the any addition and subtraction that needed to simplify your function. Then you only do one time integration, then with substitution with your a and b, then this is how you get your answer. Okay, so for the last part is what we call as volume. Okay, so it's roughly the same thing for when we discuss for the area. The only difference is that the area that you are shaded is going to revolve at the x-axis or y-axis for 360 degree. Okay, so this is how exactly the area will become what is that called, a volume. Okay, so if let's say you have something like this, so for example this is the curve. Okay, so you can imagine if what I try to do here is I try to revolve this area, So in a degree of 360. So when you try to revolve it, then what you will get? So you can imagine that this thing, okay, is getting revolved. So meaning that it will be turning and revolve. Okay, then you will get like a solid geometry. Okay, so this is what you will have. So this is like your A and B. So if let's say we want to find the volume here, so the same thing, the volume will be equal to, so the range is the same like how we actually deal with the area just now. So from A to B, but something special about the volume is that you must make sure that you have a pi. Okay, maybe let me write the pi in front. Okay, from A to B, then after that don't forget you have your pi. So this one, the volume is actually revolved from a area that is between the curve and the x-axis as well, so that's why it's going to be dx also. Okay, so since you are doing dx, so that's why inside here it should be your y, right? Or in another term your fx lah. So if you are integrating the y, and you must make sure that you need to y square it. All right, so if let's say your f of x is x squared plus 1, so meaning that your y squared should be x squared plus 1, the whole thing inside a bracket. Okay, so the other one is the same thing, but it's going to be revolved about the y-axis. So meaning, for example, if let's say you have something like this, okay, then this is your A to B. Then after that, if let's say this is my y-axis, then how is that going to look like? Okay, so I'll have this curve. So you imagine this thing is going to revolve for 360. So revolve to 360. So same thing happen here. So this is what you will get. Okay, so this is like a volume, also a solid as well. So that's why when you want to find this volume, then what you will need to do, same thing, pi, okay, from A to B as well. But in this case, you are the area here is between the curve and the y-axis, right? So that's why dy. So since you are doing dy, so that's why the equation that you are putting it should be x squared. So because when you try to write x equals to what, mean that it will be in terms of y. So this is how you integrate it. Okay, so it's the same thing. If let's say in this one you are not familiar with fx, then what you can try to do is just ab. Okay, so this is basically your y lah. So if you want to deal with the area for the dy here, meaning it will be a to b and then x dy. All right. So something special about volume is that it is not like area which you have positive and negative. So all the volume will give you a positive one. Yeah, because you can imagine your function is going to be square. So when you square anything, you should be able to get the value as a positive one. Okay. So in the recap, actually, I'll try to skip the part for improper integral, because that part will not be that important when we move on to P3. Okay, so I think that's it for the recap part. So just just a quick idea for you when you started your P3 integration, right? It's most likely to be more on the part where we learn more integration skill. So it's not that like we learn more application, like instead of doing area and volume, then what kind of other application that we can do. So it's basically that we try to learn other kind of integration skill. So meaning, for example, how we actually integrate natural logarithm, how we actually integrate trigonometry and some special kind of function. Okay, so that's it for the recap and also the introduction part. So let's move on to the first part of the lesson. Okay, so for this first lesson, we are not going to do something that very difficult yet. So basically, we are going to use the idea that we have learned previously in differentiation, and we try to reverse the process so that we can try to find out the integration of these two special functions, which is the first one, the exponential function, and the second one is actually we try to deal with the natural logarithm. Okay. Okay, so let's start with the first part, which is the integration for the exponential function. Okay, so in topic 4, we know that for differentiation for exponential function, right? So if let's say you have a function that is e to the power of x, then what you have when you do differentiation, you will get exactly same thing, which is natural base e as well. Okay, so the other one, if your indices for the natural base is not longer to be x anymore. So if you have any function as the indices, so when you actually differentiate it, then what you will have is the derivative for the function. You will need to multiply with your original function. So this is what you have, right? So meaning, for example, e to the power of 2x, then meaning it will become 2e 2x. All right, so since we know that integration is the reverse process of differentiation, right? So how is that going to look like? So for example, if let's say we need to integrate for the e to the power of fx. Okay, so how is that going to look like? Yeah, so we try to create a general one. Then after that, we try to from there we try to come up with another more useful one for this part of lesson. Okay, so you see what we try to do just now, right? Is we differentiate the function that we have as indices, then we multiply, right? Then the other one is just copy like exactly the same. So if it's the reverse, what is the reverse process of multiply? It will be divide. So that's why when we actually do e to the power of fx, then when we try to do it for the integration, then what we'll get? So we will get 1 over the integration. So e fx and plus c. Okay, so in another word, if you want to combine them together, meaning that what you try to do is e fx, then you divide by whatever that you get for your derivative for your function. Okay, so this is like the general idea of it. Yeah, so but in your syllabus, right, you can see that the thing that they try to mention here is for the integration for e to the power of ax plus b only. Okay, so I mean in a long run, actually I recommend you to know how to do this instead of like using ax plus b only, because when you move on to like harder level, like when you started your uni and so on, right, the function that you will be dealing might not be only ax plus b. So meaning that maybe when you try to memorize like ax plus b, then after that, how if you get like x squared plus 4 and so on. Okay, but this one is a general idea which you can use in all different function. Okay, so from here what we can get is, if let's say I want to integrate ex, then what do I have? So you can imagine 1 over what is the derivative for the function. So it's x, right? So you get 1. So you differentiate x, you get 1. Then after that is the exactly same thing, then plus c. So this is, sorry, in this case, your function is x, right? So that's why this should be x and then plus c. So for your answer, it will be e to the power of x plus c. Okay, so which is true because we know that after you differentiate ex, you get the same thing. So meaning uh, if you actually integrate ex, then you should get back exactly same thing as well. Okay, so the other one, let's look at the part for ax plus b. So how is that going to look like if you integrate e to the power of ax plus b? So 1 over f prime x. So what do you get when you try to differentiate ax plus b? Then you will get a, correct? So 1 over a. Okay, then what do you left? E to the power of ax plus b. Okay, so in another word, when you try to do integration, you will still need to do derivative for the function here, but instead of become multiply, it actually become divide. Okay, so these two, because in your syllabus you are only dealing with all the linear, so that's why you can just remember these two formula for an easier course lah. But I mean, of course, if you can, then you can try to just remember this. I mean, it's the same thing lah. So you will need to just find the derivative and divide the derivative. Okay. All right. So let's move on to the three example that we have here. Then after that, we'll move on to the second section. Okay, let's look at example one. Let us just write down the formula that we got just now. Okay, so when you integrate e to the power of fx with respect to dx, okay, so when you actually integrate, then you will need to divide the derivative that you have for the function. Okay, so e fx and remember plus c. Okay, so it's fine also if you want to use the idea for e ax plus b. So what you will get, you will actually, sorry, dx. So you will actually get 1 over a, because ax plus b, after you differentiate, then you get a. Okay, then e to the power of ax plus b as well. All right, then plus c. Okay, so let's start with number a. So integrate e to the power of 3x dx. Okay, so differentiate your function here, 3x. So after you differentiate, you get 3, right? So that's why 1 over 3 e to the power of 3x plus c. All right, as simple as that. So move on to b. Same thing. So integration for e to the power of negative 2x with respect to x. So integrate your function, differentiate your function. So, and divide it. So negative 1 over 2 e to the power of negative 2x plus c. Okay. All right. So let's move on to c. So same thing as well. So e to the power of 5x minus 4 dx. So when you integrate it, then 5x minus 4. So when you differentiate, then you get 5. So divide it 1 over 5 e power 5x minus 4 plus c. Okay, so for D, yeah, you can see that for this question is a bit different. So if let's say you have a square root, meaning that we can always change it into indices, right? So that's why e x plus 1, the whole thing to the power of 1 over 2. Okay, so let us try to simplify it first, because we we try not to use anything that's composite. So as this one, you also know that you can multiply them together, right? So e 1 over 2x plus 1 over 2 dx. All right, so after you have this, then you can just do your integration. So 1 over 2x plus 1 over 2, when you differentiate, you get 1 over 2, right? So 1 divided by 1 over 2, you get 2. So e 1 over 2x plus 1 over 2. Okay, plus c. So if you want your answer to be like simplified in this case, then you can always change it back as well. Okay, so 2e, then after that, your power here is x plus 1, right? So it's basically still the same. So that's why you can just leave your answer like this. All right, yeah, it's basically I'm doing it back last, so 1 over 2, meaning that the square root for the whole thing. Because you can realize that for the whole process, right, for the function part, it actually doesn't change. So what we are trying to do here is so that we can see the function clearer, so we know that after we differentiate what we get, so we are able to do like 1 over the derivative. Okay, so you can leave your last answer as this to be like more simple. Okay, so move on to e. So yeah, don't worry, it's just going to be the exactly same thing, but maybe we need to do some work before we actually start the integration. So we will need to use the knowledge for previous chapter, which is in indices, use the principle to help us to combine them. Okay, so the differentiation, so you will need to expand it. So what you will have. So okay, let us just try to write it down first, so I do not want to like confuse you later. Okay, so change this in this form, then it will be easier for you to actually expand it. All right, so now you can see this clearer. So ex multiplied by ex, you have e to x. Okay, so ex x is going to be minus 2x, right? So you have negative x. So negative 2 e negative x. all right, and then plus e negative 4x. All right, yeah, so you know that when you multiply the exponential function, the indices for your number should be added together. Okay, so this is what you have. So now we can proceed with the integration. So 1 over 2, I mean, if you want, then you can always write it in such a way that e2x dx minus 2, then differentiate e negative x dx plus integrate e negative 4x dx. Okay, so this is what you can try to do if you want, but I mean, there's no problem also if you straight away skip from this step to the last step. Okay, so as long as you understand that what you are doing last, so 1 over 2 e2x. Okay, so negative 1, so when you bring it out, then negative 2 divided by negative 1, you get positive 2. Okay, so e negative x as well, negative 1 over 4 e negative 4x, and don't forget plus c. Okay, so you can always just leave your answer like this, or if you want to, then this one you can just change it into 2, then over ex, then negative 1 over 4, then the whole thing you can write it as the denominator become e4x. Okay, so let's move on to the next one. Okay, so let's see number f. Okay, so for f, the integration for ex plus 1 minus 2 over ex, square the whole thing. Okay, so what we can try to do before we square is we try to simplify first. Yeah, I'm sorry, the background today is a bit, yeah, noisy in that sense. Okay, so yeah, I mean, you can hear the birds and the dogs. Okay, so when we try to simplify, then we try to split it into two fractions. Okay, so minus 2 ex then square. Okay, so in this case, after you simplify it, then it will be easier for you to actually square it. So ex plus 1 minus ex, then you get e to the power of what? Yeah, so you're left with 1 only, right? Then after that, minus 2 e negative x. Okay, so now we can try to expand it. So same thing, maybe we can write it down first so that it's easier for us to see. Okay, so let's expand it. So e1 times e1, then you get e to the power of 2. Okay, so minus 2 e1 minus x. Yeah, then the same thing again. So if you want, then you can try to straight away change this into 4 also, okay? And then plus 4 e. So when you plus them together, negative 2x. All right. So now let's try to simplify it before we move on to the integration. Negative 4 e1 minus x plus 4e negative 2x dx. Okay, so now we can start to do the integration. So e2, when you integrate, what do you get? So if it's e2, right, this is not even a function also because you do not have any variable. E2 is basically a constant. So what do you have? It's just e2x. Okay, then after that, you need to continue. So plus, so 1 minus x, when you differentiate, you get negative 1, right? So become plus 4 e1 minus x. So for this case, then it will be negative 2. So when 4 divided by negative 2, you get negative 2. Okay, e negative 2x. All right, and plus c. Okay, so that's it. So let's move on to the next questions. Okay, so number 2, you should have no problem with this as well. It's just a practice for you. So for the finite integral. So 9e3x minus 1 dx. Okay, so you just do the same thing. So integrate it, or we can take out the constant first. So 1 to 2 e 3x minus 1 dx. Okay, so when we try to integrate, then what we have, so you got 3, right, for the derivative, so you will have 1 over 3 outside. Okay, then after that, e 3x minus 1. And this thing is going to be substituted into 1 and 2. Alright, so you get 3 here. Then after that, we can move on. So E, 3 substitute 2 minus 1. And then minus the other one, which is substitute 1. Alright, so equal to 3. And then E, 6 minus 1, you get 5. Okay, then after that, 3 minus 1, you get 2. Okay, so you can just, what is that called? Factorize it. So 3E2, so you're left with E3 minus 1. Okay, so but I mean, of course, you can see that what I try to do is I straight away 1 over 3, then after that I multiply with the constant I have in front. So it's the same thing if you don't want to do that. So your 1 over 3 is over here. So when you solve for this 2, right, then you will get the exactly same thing when you move on. Okay, so meaning that you have 9 outside, then after that 1 over 3, 1 over 3. Yeah, but as you proceed, you actually get the exactly same thing. Okay, so let's look at the last example. Okay, so number 3, given the diagram is a graph for y equals to x squared plus e to the power of negative 2x, find the area for the shaded region. Okay, so from the recap just now, you should be able to continue this already. Alright, so for us to find the area, then what we try to do is get the range. So for this case, it's 1 to 2 lah. Okay, so this is the area between the curve and the x-axis. So that's why you are going to integrate it with respect to x. So that's why inside here, it should be your y. Okay, then now we can substitute your equation of y here. X squared plus e negative 2x dx. Okay, so equal to, then now we can start to, if you want to, then you can try to split it into 2. Okay, so I mean, it will be less confusing later. Okay, meaning when we minus, then we are just minusing it like independently, like without combining them together. Okay, so how about this part? So when you try to integrate x squared, then what do you have? You have x cubed divided by 3, correct? So plus 1 divided by the power. So from 1 to 2 as well. And plus the other one, so negative 2x. So when you integrate, you get, sorry, differentiate, you get negative 2. So divide it, then you get negative 1 over 2. Okay, so depends on you whether, okay, maybe in this case we should write inside lah. Yeah, but as you can understand, meaning when you substitute it, then when you multiply, then it's the same thing if you put negative 1 over 2 outside. So e negative 2x, then after that 1, 2. Okay, so now we can start to substitute it. So 2, yeah, sorry, this is not a good demonstration, but yeah, I just want to keep everything like much more tidy. Okay, 2, 3 over 3 minus 1, 3 over 3. Okay, and then plus, so you have substitute 2 first. So this one is 1. Then you have the other one, negative 1 over 2e, negative 2, 2. Okay, then after that, this is the first one, then minus negative 1 over 2e, negative 2, 1, second one. Okay, so just substitute and find out the answer. So 8 over 3 minus 1 over 3 plus negative 1 over 2 e to the power of negative 4. Then after that, it's going to be plus as well. Okay, so because negative, negative, right? So you get 1 over 2 e negative 2. Okay, so now we can try to combine them together and see which is the term that we can actually simplify. So you get 7 over 3 minus 1 over 2 e negative 4 plus 1 over 2e negative 2. Okay, so there's nothing else that we can actually simplify. So what you want to do is you just use your calculator to get your answer. Okay, so write your answer in 3 significant figure. So you will get 2.39 units square. So this is the answer in 3 significant figure. Okay, all right, so that's it for the first part. So actually you realize that it's quite simple, but yeah, I'll let you know that you can see in today's exercise it won't be any partial questions. So it's just like starting from this for this lesson, which is a basic skill for you to move on. So meaning that after we learn more content in the future lesson, right, you will realize that you will need to know how to apply what you have learned now, then together with other skill. Yeah, so that's why it's just like something for you to pick up. For example, this is like a product rule or a quotient rule that you will use, that you will always use it in different kind of scenario. Yeah, so you must make sure that you know how to integrate for the natural base. Okay, so let's move on to the next part. Okay, so for the second part, we'll be discussing for the integration of the function of 1 over ax plus b. Okay, so same thing. So let's try to go from the concept that we have learned previously in differentiation for natural logarithm. Okay, so I mean, we know the ln, right? So that's why. So if we have y equal to a natural logarithm of x, so when we try to do dy dx, can you recall what do you get? So you have 1 over x. Okay, so the same thing, if let's say your x is not longer to be x but a function, so when you try to do dy dx, then what you will get? So you will need to differentiate your function, then it will become your denominator, sorry, your numerator, and you divide by your fx. Okay, so since the integration is the reverse process, so it's the same thing. So how is that going to look like? So let's try to like write out a general one first. So meaning that I mean in this case we do not need to change it like whether divide or multiply, because you can see this is like exactly different form. So meaning that the first one is if let's say I have a integral form over a original function, then I know that I will be getting natural log fx. Okay, so in another word, maybe I try to give you an example here. So if I have 4x squared plus 3x, and this is 8x plus 3. So you can see that it's a derivative divided by the original function. So what is this? This is just natural log for 4x squared plus 3x. Okay, as simple as that. Okay, so let's move on. Yeah, but then yeah, I want to let you know, right, this is the general one. So but in your textbook, right, they try to split it into two different part. So meaning that because in pure max 2 they are not learning this, so that's why we are looking at different scenario as well. So I mean we will try to look at this part but in another lesson. So for today's lesson we are going to look at this only. Okay, so meaning that we have 1 over x dx. So when we try to integrate, then what do you have? Then you have natural log x. Okay, so the reverse, right? So same thing. So if I have 1 over ax plus b, okay, that's the idea for us to solve today, right? So what do you have? What do you think? Yeah, so you can realize that what you want based on the equation here is that when you use the derivative to divide by the original function, then you get natural log fx. So how about this? So you look at ax plus b, right? So when you actually differentiate it, then what do you get? You get an a, right? So what you need to do is, let's say, for me to actually change this into natural log fx, then you might need a as your numerator. So only in this form, then you can say that a is the derivative for ax plus b. So that's why when you integrate, then you get ln fx. Okay, so but then I mean we can't actually just simply add an a here. So the original function is 1. So what we need to do, we need to divide the a that we multiplied just now. So this is what we have. And then now only you can integrate it. So 1 over a, this is the constant that you have outside. So a over ax plus b is just f prime x divided by fx, right? So now you can change it into natural log already. Okay, so as simple as that. So meaning that you can just remember for anything that is 1 over x plus b, you need to do 1 over a natural log ax plus b plus c when you try to integrate it. Okay, but of course, if you were to ask me, then I would recommend you to just learn about the first one because this formula will be given in your exam, but then this formula will not be. Yeah, so this is just like a easier one for you to just start off with this. So that's why they try to put it in like different lesson that you're going to only learn this form in another chapter. Okay. All right, so now let's look at the second part, which we try to look at this special function in another way. Okay, so we need to find out the integral for 2 to 3 for the function of 1 over x. Okay, so let's try to draw the graph first. Okay, so yeah, this is obviously not a very nice graph, but yeah, I mean, I believe you can draw better on your paper. Sorry for the bird chipping sound again. All right, so let's try to shade the integral that we want. So from 2 to 3, so it's like here. Okay, then the other one is from -2 to -3, which means it's like here. Okay, yeah, because of the not so nice graph, that's why you can see that it's I mean there's some difference, but if you draw it properly you should be able to see they are, I mean, using a logic idea of the graph is symmetrical, you should know that this area and this area should be the same, right? So since the graph is symmetrical, the shaded region that represent the two integral are actually equal in magnitude, meaning that if this is 2, then obviously this will be 2 as well. It's just that it's going to be one positive and one negative. Okay, so we know that since one of the area is below the x-axis, so we know that if let's say in this case this will be the positive one, right? So 2 to 3 and then 1 over x dx is going to be the negative for the part that is negative, because negative, this is how you get a positive one. Okay. Okay, so let us try to solve it. All right, so just now we already learned that how to do 1 over x, right? So for the formula for 1 over x, we will have natural log x. Okay, so now let's try to do the integration. So when I try to integrate 1 over x, then I'll get ln x. Okay, then 2, 3. So what I will need to do is I will need to substitute it. Then this is how I get natural log 2. Okay, sorry, natural log 3, the upper boundary, minus the log 2. Okay, then after that, when I try to combine them together, then what do I have? So I will have, yeah, log minus log, then you can combine them by divide. So log 3 over 2. Okay, so this will be the answer for the area. So meaning the area here is log 1 over is natural log 3 over 2. Okay, so meaning that if we know that the magnitude are the same in terms of magnitude, so what we try to do here is we should get an answer that is negative log 3 over 2. Correct, right? Because the idea of it is that we will get the same magnitude, but then in this case, because it's below the uh, x-axis, so that's why you are getting an area for negative. Okay, but now let's try to do, so you have ln x, right? then after that, when you want to substitute, then what's the number that you need to substitute? It's like -3 to -2. So meaning that when you do the substitution, it's going to be like ln -2 minus ln -3. Okay, but you have a problem up to here. What is the problem? So if you can recall, right, every logarithmic uh function, for example, log AB, the A and B must be a positive number. So if let's say now we are doing ln, so it's going to be log E. So natural log A, the A must be positive as well. So if you try out with your calculator, you can realize that for natural log for -2, right, you always get a max error. So you can try out like all the other negative number, it will always give you max error. So that's why for your natural log function to be true, your A must be positive. So how should we do that? So you can see in this case, right, then how do we actually change a number from a negative to positive? Then we will need to do square root. So how it, sorry, not square root, we'll need to do modulus. Okay, so how is that going to look like? So let's try out. So if let's say, just now we have natural log of 3, 2, right? So instead of doing like -2 and -3, let's try to write it in such a way. -2 minus -3. Okay? And let's check whether you get the answer that you want or not. So equal to natural log 2, right? Minus natural log 3. Okay? So what you have here? So it becomes 2 natural log 2 minus natural log 3. So ln 2 over 3. Okay, so now let's try to check the calculator whether you get the same answer but then different. I mean, obviously, if you don't do the last step, you can actually see that like basically 2 minus 1 and then 1 minus 2. Yeah. So if you want, then we just use the calculator to check it. So you can see for the first area, which you have natural log 3 over 2. Okay, so the answer that you have is 0.405. So if you change it into 2 over 3, okay, then you'll have the exact same value but in negative. Okay, so meaning that what we can have here is that every time when we actually want to solve this kind of question, because the function that we have when we do integration, right, is just in the reciprocal form. So it's not necessary that your x has to be a positive. But then when we try to solve it in integration, we must make sure that it's in positive. So that's why instead of writing natural log of x, we will always write natural log modulus x. Okay, so it's the same thing for the other one. So it will be 1 over ax plus b dx, okay, equal to 1 over a natural log, and you must make sure that your ax plus b is always positive as well. Okay, so this will be the much accurate function. Okay, we are not discussing for the part for the general idea here, but then I mean you can get the idea also because you are natural log it, so that's why the function here has to be a positive one as well. Okay, but we'll just move on with these two first, then after that we'll cover for the part when we do in the future lesson. Okay, so let's try to look at few example before we end the lesson. Okay, so same thing, let us just write down the formula. So when you integrate 1 over x with respect to x, then you will be getting natural log x plus c. So the other one is when you integrate 1 over ax plus b dx. Okay, then you will have 1 over a natural log, then ax plus b plus c. Okay, so it's actually the same thing that you can remember as the exponential function just now, but it's just that now you have a natural log. So but the idea is still the same, where you need to differentiate the function, then you divide by the derivative that you have. Okay, so number A, So you can realize that the full two formula that we have here, right, both the numerator is a. So that's why the first thing that we might need to do for all these questions is to bring out the constant. So 2 1 over x dx. Okay, so you just integrate whatever is in your integral. So you have 2 ln x plus c. Okay, so in this question, they also want you to write down the value of x in which the integral is valid. So that's why in this case, your x must be greater than 0 lah. Okay, yeah, meaning that you will always natural log a positive answer. Okay, B. So the same thing. The first thing that we try to do is we take out the constant that we have. So in this case, you have 4 outside. Then after that, 1 over 2x plus 1 with respect to x. Okay, so 4. All right, so now 1 over. So the same thing, you just differentiate what you have for the denominator. So you have 1 over 2, okay, and ln the function. All right, and then don't forget your plus c. So you will get 2 natural log 2x plus 1 plus c. Okay, so the same thing, 2x plus 1 has to be greater than 0. So that's why your x should be greater than negative 1 over 2 so that you can have your natural log as positive. Okay, c 6 2 minus 3x dx. So same step, try to bring out your constant. Okay, differentiate your denominator. So in this case, what you get, negative 3, and divide by negative 3. Okay, that natural log your whole denominator. All right, and then plus c. So what you get, negative 2. Okay, and then natural log 2 minus 3x plus c. So the same thing in this case, 2 minus 3x must be a positive for your ln to be valid. So that's why x is greater than, what is that? So you bring it, sorry. So it will be smaller than, okay, 2 over 3. Okay, all right, so move on to number 5. Okay, so same thing, but this is in finite integral. Okay, so 2 to 3 6 2 over 3x dx. Okay, so the same thing, bring out your constant first. So now integrate your denominator and divide it. So in this case, negative 1 over 3. Okay, so the same thing, then natural log for the denominator. All right, and then 2, 3. Okay, so now you can take out the constant first so that you do not need to deal with the fraction later. So now you have natural log, then you need to substitute. Maybe let me try to use the other bracket. Okay, natural log for 2 minus 3 multiplied by 3. Okay, then the other one is minus natural log 2 minus 3 multiplied by 2. Okay, so equal to negative 2. So for here, what can you realize? So 2 minus 9. So you realize that you get a negative number here. So meaning that what do you actually need to do? So in this case, you must make sure that it's always positive. Okay, so that's why you need a modulus. All right, so in this case, what you have, so you have modulus negative 7. Okay, and then minus natural log. So in this case, you same thing, you will need a modulus as well. So 2 minus 6 give you negative 4, right? Okay, so now we will need to write it in positive so that we can continue. So natural log 7 minus natural log 4. Okay, so combine them together. So if minus, meaning that we can always write it in divide. So 7 over 4. Okay, so if it's negative, can we try to change it into positive? Any idea how can we do that? Yeah, So instead of like doing this, maybe you can try to expand first. So meaning negative 2 natural log 7, or in an easier way, meaning that 2. So we just put the negative inside the bracket plus. Okay, so we'll leave the constant to be positive outside. So in this case, it will be natural log 4 minus natural log 7 already. So meaning that we will have natural log 4 over 7. Okay, I hope that you can get what I'm doing. So, okay, meaning that it's like this. Alright, so I can always combine these two, right? So 2 natural log, then what do you have? 4 over 7. Alright, so this will be the last answer in this case. So make sure that your last answer should be in a single logarithm. Yeah, so normally that will be the case lah. Okay, so let's look at the very last questions. Okay, so let's look at the last questions that we have here. So let's start with sketching the graph. Okay, so the same thing, I believe that you can draw better on your own graph. Okay, mark on your sketch the two areas represented by -2 to -1 and 5 to 6. So 5 to 6, it will be somewhere here. Okay, so same thing for the other one, for -1 to -2, then it will be somewhere here. Okay, so C, explain using the symmetry of reciprocal function why is this function equal to this function. So you can just answer the vertical asymptote. Okay, meaning the line that we draw just now. So you can just check it by using, when you substitute 2 inside the function, right? Then you'll get 2 minus 2. So 1 divided by 0, then you get an infinity. So that's why this graph will never reach the point for x equals to 2. Alright, so the vertical asymptote is at x equals to 2. Okay, and you will realize that the graph is symmetrical. So as what you can see, so this is like the point that is symmetrical to each other, right? So this is like the first box, second box, and the third box is the box that we shade. So the same thing, 1, 2, 3. So this is the third box as well. Okay, so you can just explain it. So the interval from -2 to -1, and also 5 and 6 are symmetrical. Okay, then after that, therefore, then you just answer, therefore, the shaded area are equal in magnitude. Okay, so if you want to explain further, then you can explain also the part that below the x-axis. Yeah, so the difference is just that the so yeah, to explain further, meaning that you can always say that the area for the interval -1 to -2 is actually negative. Yeah, so that's why this is equal to this. Okay, all right, so let's move on to D. So calculate the two integral in part C and verify the result. So we can just substitute. So -2, -1, 1 over x minus 2 dx. Okay, so let us start to do the integration. So we have logarithm. So x minus 2, right? So when you differentiate, you get 1. So that's why I don't write anything in front. So because divide by 1 is just basically the same thing. Okay, and don't forget your modulus. All right, then you are going to substitute -2 and -1. So what do you have? You have natural log. So when you substitute -1, and the other one is you need to substitute -2. Okay, all right, so equal to, so natural log for 3 minus natural log of 4. So what do you have? You have natural log 3 over 4. All right, so let's move on for checking the other one. So this is the one that given. So -5, 6, 1 over x minus 2 dx. Okay, so I'll get the exact same thing after I integrate it, but then the number that I'm going to substitute is going to be 5 and 6. So 6 minus 2, and then 5 minus 2. So I have natural log 4, and don't forget I have a negative, so I need to, yeah. All right, so negative the whole thing here, natural log 4 minus natural log of 3. Okay, then we just rearrange it and expand it, so I get natural log of 3 minus natural log of 4, which gives me the same thing. Okay, so that's why I can always say that the first integral is the same with the second interval with negative. All right. Okay, so let's move on to E, the last question. So we'll verify whether the integral 1 to 3 exists or not and explain your answer. So 1 to 3 meaning that what you want is from 1 up to 3. So meaning that these are the area that you want to find. So what do you think? Do you think that the integral that exists? No. So the idea is that you can obviously see that you have an asymptote at x equals to 2. So that's why all the area here, because this curve will never touch the line for x equals to 2. So that's why you will have an infinite area. Yeah. So that's why the integral does not exist. Okay. So how do you actually explain this? Yeah. The interval from 1 to 3, okay, includes the asymptote and the area across the asymptote will be infinite. All right, so this is how you answer. So yeah, I mean, this question is for your understanding, meaning that for you to understand what you are doing. I mean, you won't be, so as what I say, this is like a basic skill that you need to pick up. So we will be like using all the skill then combined with the future knowledge that we are going to learn, then that's the part where your partial question come in. Okay, the area across the asymptote is infinite. Okay. Alright, so for this part, actually, you are going to use it also for the part where, if you can recall when we first started to learn partial fraction. So for the partial fraction, this is somewhere where this integration skill come in. So we'll be cover this part in the future lesson as well. Okay, so that's it for today's lesson. So I hope that you can understand and take your time for your exercise. Yeah, that's it. Thank you.